Welcome to CodeXInnovate. Here we break down tech and coding into simple steps for everyone. Today we're going to build a simple AI model using Python. Even if you've never coded before, let's get started. First, let's set up our coding environment. We'll use Python, a popular programming language that's great for beginners and experts alike. An IDE, or integrated development environment, helps us write and test code more efficiently. We'll use PyCharm, which is free and user-friendly. Now, before we dive into the actual code, we'll install some libraries. Libraries are collections of pre-written code that we can use so we don't have to reinvent the wheel. We'll use pip, Python's package installer. Think of it like an app store for Python libraries. Open your terminal or command prompt and type the following commands. Now let's dive into coding. First, we'll import the libraries we installed. Type the following code at the top of your file. Let's break down each line. NumPy imports the NumPy library and allows us to use it with the shorthand NP. Load iris imports a function to load the iris dataset. Train test split helps us split our data into training and testing sets. Decision Tree Classifier imports the Decision Tree Classifier model we'll use. Metrics provides tools to evaluate the performance of our model. By importing these libraries, we're bringing in powerful tools that simplify our coding process. Next, we'll load the dataset. For this AI model, it is going to identify the species of iris flower based on certain parameters. Type iris equals load iris. This command loads the iris dataset into our program. The iris dataset is a classic in machine learning. It contains measurements for 150 iris flowers from 3 different species: Iris setosa, Iris versicolor, Iris virginica. Each flower has 4 measurements: sepal length, sepal width, petal length, petal width. Our goal is to create a model that can predict the species of an iris flower based on these measurements. Now, we'll split our data into training and testing sets. Type x equals iris.data, y equals iris.target. Here x contains our features, the measurements, and y contains our labels, the species. Next, we'll split the data. Here's what's happening. Train test char split divides the data into X train and Y train, used for training the model. X test and Y test, used for testing the model. Test size equals 0.3 means 30% of the data is reserved for testing. Random state equals 1 ensures the data is split the same way every time for consistency. Why do we split the data? We want to train our model on one set of data and test it on a different set to see how well it generalizes to new, unseen data. Tip: if you change the test size parameter, say to 0.2 or 0.4, you'll change the proportion of data used for testing, which can affect the model's performance. For example, a smaller test size might not provide enough data to accurately assess the model. Now, let's build our decision tree model. Type CLF equals Decision Tree Classifier. This creates a new Decision Tree Classifier instance called CLF. Next, we'll train the model. CLF equals CLF.fit, X train, Y train. Here's what we're doing. CLF.fit, X train, Y train trains the model using our training data. Why a decision tree? A decision tree makes predictions by learning simple decision rules inferred from the data features. It's like a flowchart where each internal node represents a test on an attribute. Each branch represents the outcome, and each leaf node represents a class label. Experiment. You can adjust parameters to see how they affect the model. For example, setting max depth equals 3 limits. How deep the tree can go. CLF equals Decision Tree Classifier. Max depth equals 3. Limiting the depth can prevent overfitting, but might reduce accuracy. Outcome: Changing max depth might result in a lower accuracy on the training data, but could improve performance on unseen data by simplifying the model. Now, let's see how well our model performs. Type ypred equals clf.predictXtest. This line uses our trained model to make predictions on the test data. Next, we'll evaluate the model's accuracy. This compares the predicted species, ypred, with the actual species, ytest, and calculates the accuracy. Understanding the output. The accuracy score ranges from 0 to 1. An accuracy of 0.95 means our model correctly predicts the species 95% of the time. Experiment. Tip: try changing the random state parameter in train test split 42. Changing random state alters how the data is split. This can lead to different accuracy scores. Example: using random state equals 42 might result in an accuracy of 0.93 instead of 0.95, showing how data splitting impacts performance. And there you have it. You've built your first AI model in Python with no prior experience. Feel free to experiment with the code. Try changing parameters like max depth or random state. See how these changes affect the model's accuracy. Have questions or ran into issues? Drop a comment below. I'd love to help. Don't forget to like this video and subscribe to CodeXInnovate for more tech and coding tutorials. What would you like to learn next? Let me know in the comments.